Returning to the miles per gallon data set, we will now summarize some of this data visually instead of with a single numeric value. First, to summarize numeric data, we'll use the appropriate graphic, which is a histogram. So in this case, we'll summarize the city fuel efficiency data, and in R, to create a histogram, we'll use the hist function. So RStudio places the plot in this bottom right panel here under the Plots tab. So what does this tell us? So first, to simply read a histogram, we say, well, between a city fuel efficiency of 10 and 15 miles per gallon, there were, let's see, over 80 cars. Similarly, between 15 and 20, there were over 80 cars. Down here, between 30 and 35, there were maybe not even 5, very few. What else do we see? Well, the vast majority of fuel efficiencies are between 10 and 20 here. Further, we can sort of see how this matches what we saw numerically before. Recall that we had a mean of 17, roughly, and a standard deviation of about 4, so 17 is in this bar here, and 17, if we go 4 this direction, we're about here. If we go 4 to the right, we're about here. We see that the vast majority of deviations are sort of within 4 of the mean, and that's where the vast majority of the area of this histogram is. We see that the histogram sort of matches the numeric summaries we saw before, but it tells us all of this in a single plot. It also shows us, for example, that the range is roughly between 5 and 35. So we have one quick visual way of relaying a lot of information about this data here. This plot isn't particularly visually appealing, and in particular, some things just look very ugly, for example, passing through this R variable name here automatically. So we can fix this with some additional arguments to the hist function. We see a number of them here. So here we're going to modify, say, this label. Here we're going to give it a title. Let's run this and see what happens, though. So a few other things have changed as well. So instead of there being 6 bins, I now have 12, and I gave it some colors, which I happen to like. We'll see here, by increasing the number of bins here, we see the information is still the same. 17 is sort of a very common value. Most of the values are within 4 of that. We do see a little bit more information where there's sort of very, very few cars out here, and they're sort of almost separated from some of the other data. So these are sort of, I don't want to call them outliers, but we'll call them sort of unusual values. Here we had a numeric variable. If instead we wanted to summarize a categorical variable, visually we would have to use a bar plot. In R, we first would have to summarize the data, in this case the drive variable, as a table, and then pass that to bar plot, and we get a bar plot. This isn't the most useful graphic in the world. It doesn't really tell us anything that the numeric summary didn't tell us, but again, we can clean this up a little bit with some additional arguments to the bar plot function. Bar plot and histogram were ways of visually summarizing a single variable, but often what we would be interested in is the relationship between 2 variables. For example, if we wanted to understand the relationship between a numeric variable and a categorical variable, we would use box plots. So let's first create one. And this is actually multiple box plots, one for each of the possible values of the drive variable here. And we also, our y-axis now is the highway fuel efficiency. So a number of things. First, we're using a new syntax here. So instead of saying mpg $sign and then extracting a variable, the box plot function has this data argument. So it's saying, essentially, in this function call, we know we're going to be using this data. So then over here, in what we'll call the formula, we can directly access the variables. So this says I want to understand the highway variable as it relates to the drive variable. So then another way of thinking of this is this variable here will be the y variable. This variable here will be sort of, in this case, the x variable. So for each possible value of drive, four-wheel drive, front-wheel drive, and rear-wheel drive, we have box plots. So this gives us a quick way of comparing highway fuel efficiency for the 3 different drivetrains. Quick note about box plots. So what is a box plot? The most important part of a box plot is the box. And so in this box we have the thick line here is the median, so that's telling us where the data is split in half. The lower part of the box is the first quartile. The upper part of the box is the third quartile. Depending on the strict definition of a box plot, how the whiskers are created can be slightly different, but know that this tells us where most of the rest of the data lies. And then sometimes you'll see dots outside of the whiskers, and those represent data points that are sort of very far from the box relative to the size of the box. So we can sort of think of these as sort of rather unusual observations. So before talking about the box plots more, I'm going to again rerun boxplot with a number of different arguments here. We'll talk about some of them. So again, modified some colors, I modified some labels. PCH stands for plot character, so I sort of modified how these dots are being created here. I also sort of increased their size with CEX. So again, this gives us a quick way to compare these things. So we see that there's a very clear difference between, say, front-wheel drive and rear-wheel drive. In general, the front-wheel drive has a much better fuel efficiency than the rear-wheel drive. So while, say, comparing four-wheel drive to rear-wheel drive, the median is lower for four-wheel drive, their boxes are sort of very similar, so they're not all that different. Lastly, one of the plots that we'll use most often is a scatter plot for comparing two numeric variables. There's a good chance you're already familiar with this, so here we're saying place the highway variable on the y-axis, the displacement variable, how big the engine is, on the x-axis, and then we have each individual data point plotted here. Again, this is not the prettiest plot, so we can give it additional arguments again. And here we've added some labels, a title, and we've changed the color, plot character, and size of the individual points. And we see sort of this decreasing, maybe slightly curved relationship. So the bigger the engine, the poorer the fuel efficiency. Everything we've done here would be using what we would call the base R plotting features. So these are all functions that were directly in R. There are a number of different plotting systems in R. For example, there is the lattice package, which has XY plot, and by default, a scatter plot would look like this. There's also the ggplot2 package. This is becoming probably one of the most increasingly popular plotting systems inside of R, and by default it looks something like this. I will most often use and show the base R plotting system, but you're free to use any plotting system you choose. Also, I would note that along the way I was very quickly using different arguments here and sort of saying what they did, but note that these are never an exhaustive list of possible arguments to a function. So say, for example, plot. If we look at the documentation here, there is a wealth of information about how you can modify plots. So just be aware of that. Often you'll have to sort of dig around and try a few of these things before you get the exact plot you're looking for.